This is Cambridge IGCSE for Chemistry 0620, Paper 2, Variant 2 from February-March 2020. Number 1, the formula of methane is CH4 and the formula of ethane is C2H6. Which row describes diffusion and the relative rates of diffusion of methane and ethane? The first part of the column asks for description of diffusion. So diffusion is defined as particles move from a high concentration to a low concentration. The opposite shouldn't be possible. Hence, we can eliminate answer C and answer D. Next, the relative rate of diffusion. This question is about ethane and also methane. And we see that ethane has a larger size as well as having more particles, which means that it's heavier. So we know that heavier particles actually diffuse slower. Hence, the answer will be B instead. Moving on to question number 2. Which test is used to show that a sample of water is pure? The answer for A is evaporate the water to see if any solids remain. That will not be a sufficient method to see whether water is pure or not. Why? Because if, let's say, there are impurities, some of the impurities may also evaporate together with the water. For B, heat the water to check its boiling point. That is more quantitative. That is, in fact, the way we check whether water is pure or not. As pure water has a boiling point at 100 degrees Celsius at normal conditions. Okay, with the presence of any impurities, it will affect the boiling point. So the answer for this question will be B instead. Moving on to number 3, chromatography is used to separate and identify the components in both colored and colorless mixtures. For colorless mixtures, the chromatogram has to be treated with another chemical. What is the name of this type of chemical? In chromatography, we're essentially observing the substances moving across the chromatogram. So if, let's say, these substances are colorless, you will need a locating agent for that. So that will be D. All right, moving on to number 4. Lithium reacts with fluorine to form the compound lithium fluoride. Which statement about this reaction is correct? So lithium is a group 1 element, which means that it will donate electrons and form a +1 charge. For fluorine, all right, fluorine atom is a group 7 element, which means that it will receive an electron to turn into -1 charge. So the best answer for this question will be A. Each fluorine atom gains 1 electron. Moving on to number 5, carbon 14 and also carbon 12 are isotopes of carbon. Which statement about these isotopes is correct? Let's look at option A. Carbon 12 is more reactive than carbon 14 because the atoms have less mass. Although it is true that carbon 12 is lighter than carbon 14, but both of them are ultimately the same type of atom. So that there will never be any differences in the reactivity amongst these two particles. Okay, so there will be no difference regarding reactivity. So in B, as you read the phrase more reactive, okay, so you can eliminate this answer as well. So let's look at C and D. The reactions of carbon 12 are similar to carbon 14 because they have the same number of outer shell electrons. So the answer will be C instead. Okay, as we know that reactions, all chemical reactions ultimately depends on the number of electrons in the outer shell, not because of the number of protons. All right. For example, elements in the same group, although they have different number of protons, but the reaction that they carry out is roughly similar. Okay, so the reason why there's a similar reaction is due to having the same number of outer shell electrons, which makes them belonging to the same group. All right, so the answer is C. Moving on, number 6, the molecular structure of hydrazine N2H4 is shown. Which description of the bonding in hydrazine is not correct? As we read the options, we can see that this question is about electrons and bonding pairs. So let's just identify that first. Nitrogen atom, as you can see, contains 3 sets of bond pair electrons, which means 3 lines. Right, so the answer for this question will be B because it's asking for not correct. And we literally just found out that nitrogen atom only has 3 bonding pairs. All right, so the answer is B. For the rest of the options, actually, it's correct. Where nitrogen atom has a non-bonding pair of electrons. True, because you see, nitrogen is having an electron arrangement of 2,5. All right, so 3 of them is used in bonding, which leaves 2 electrons remaining in the outer shell, which means that's the non-bonding pair of electrons. And then we see that each nitrogen atom shares 1 of its electron with a nitrogen atom, which is true. And the last one is each nitrogen atom shares 2 of its electron with hydrogen atoms. That's true. All right, moving on to number 7. Solid X has a high boiling point. Its structure has positive ions surrounded by a sea of electrons. So these are keywords. Okay, whenever you have a structure that contains positive ions surrounded by sea of electrons, you should think of it as a metal. These are descriptions of metals. So the properties of solid X include being malleable and an electrical conductor. So the answer is C. All right, metals are not brittle and metals are good conductors. Okay, they are not exactly good insulators. Moving on to number 8, the formulae for some ions are shown. Okay, in which row is the formula not correct? All right, so remember how can we construct ionic compound formula? It's by switching the charges. Okay, so it's like, for example, aluminium oxide. Aluminium has a 3 plus charge, and then oxygen, or should I say oxide ion, has a negative 2 charge. So essentially, the ratio is 3 to 2. All you need to do is switch the numbers, and then you get the actual formula, Al2O3. So for iron 2 nitride, iron 2 is Fe2 plus, and then nitride is N3 minus. So if you see the ratio of the charges is 2 to 3, switch the numbers, and then you should be able to get Fe3N2. So the answer which is not correct is actually B. Okay, and remember to check for C and D in order to make sure that your answer is indeed correct. Moving on to number 9, the equation of the decomposition of magnesium nitrate is shown. Which volume of gas is produced when 0.1 moles of magnesium nitrate is decomposed completely? So 0.1 moles of magnesium nitrate is the reactant, right? So essentially from the equation, as mentioned many times, the equation tells us the mole ratio. Okay, so based on the coefficients of this equation, that it's 2 to 2 to 4 to 1. 2 to 2 to 4 to 1. So, okay, so that's the theoretical mole ratio based on the equation. So experimentally, you are using 0.1 moles of magnesium nitrate. The question asks for the volume of gases. So we, based on the equation itself, the products that are in gaseous form are these two chemical substances that gives you a sum of 5 moles altogether. So let's just change this mole ratio slightly into the gas products. Okay, so and then we can pretty much ignore the magnesium oxide since it's not asked in the question. We can ignore this and erase the mole ratio. All right, so it's a 2 to 5 ratio from magnesium nitrate to the gaseous products. So since you're using 0.1 volts of magnesium nitrate, that will give you it's essentially a fraction of 0.1 out of 2. So that's the conversion factor. So you take 5 multiplied by 0.1 times 2, then you should be able to get the number of moles of the gaseous particles. So that will be 0.25 mole. So how much volume does 0.25 moles of gas occupy? So essentially, remember the molar volume of any gas is 24 dm cube. So having basically a quarter of that will mean that it's 6 dm cube. All right, so the answer should be C. Okay, when I say a quarter, actually it means 0.25. In order not to confuse you, let me just use 0.25 instead of saying that it's quarter. Okay, so it's 6 dm cube. The answer is C. Moving on to number 10. Which statements about the electrolysis of molten lead to bromide are correct? So we have the electrolysis setup, and the electrolyte that we're using is lead to bromide. Oops, it's a molten lead to bromide, so the state should be liquid. Okay. Now let's look at options 1, 2, 3, and 4. Lead ions move to the anode and are oxidized. Remember, the anode only attracts anions most of the time, and lead ions are actually positive ions, so 1 is wrong, right? So 2 should be correct. Lead ions move to the cathode, that's correct, and are reduced. Okay, in fact, that's true. Remember, cathode is the electrode where reduction takes place. Okay, so moving on to 3, bromide ions move to the anode and are oxidized. That's correct as well. Okay, as we said earlier, anode attracts anions, and then in fact, anode is the electrode where oxidation takes place. So the answer should be C for number 10. All right, moving on to number 11. Aqueous copper 2 sulfate is electrolyzed using carbon electrodes. Which statement is correct? So this time we're doing electrolysis of copper 2 sulfate, and it's in its aqueous form. And we're using carbon electrodes. So remember, how do we determine which substance will get discharged at respective electrodes? It's based on the reactivity series. All right, copper will be chosen for the cathode. Okay, due to its position in the reactivity series, it's below hydrogen. All right, so for the anion, it will be not the sulfate, but instead it will be the hydroxide ion contributed by the aqueous solution. Okay, by the water and the electrolyte. So hydroxide ions gets discharged into oxygen gas. All right, so let's see. We do not form any bubbles of hydrogen. We do form oxygen gas, but not at the cathode, as this is a reaction that's happening in the anode. So copper is deposited at the anode. That's wrong as well. The last one, the blue color of the solution fades. That's correct, because your copper 2 ions, which are blue in color originally, when they get discharged, they get deposited. Okay, they get deposited on the allow me to use the correct color, which is brown. Copper gets deposited around the cathode. Okay, and as a result of that, because you're essentially sucking out the copper 2 ions from the solution, so the blue color of the solution actually fades. Okay, so answer is D. Moving on to number 12, nitrogen trifluoride NF3 is used in the manufacture of certain types of solar panels. The equation for the formation of nitrogen trifluoride is shown. The type of the bond is given, and the bond energy is given as well. Using the table of bond energies, what is the energy change for this reaction? All right. So if we were to understand this equation, it is actually a nitrogen molecule and 3 fluorine molecules. These molecules react with each other and then they turn into nitrogen trifluoride, and there's 2 of them. Okay, by dropping it out, I'm able to see how many bonds I need to break and how many bonds I need to form in order to make nitrogen trifluoride. So you need to break one nitrogen gas bond and also 3 fluorine covalent bonds. All right, so there will be 950 and also 3 fluorine bonds. Okay, that will be the energy required to break the bonds. All right. So for the next one is the formation of nitrogen trifluoride. There's 2 molecules of them, so there's actually 6 bonds. Okay, so to form bonds, there are 6 bonds for us to form actually. So it will be 280 multiplied by 6. Okay, so you can punch these numbers in your calculator and then find out how much is the energy required to break the bonds and also to form the bonds. I got 1400 for breaking the bonds, and also for the bond formation, it will be 1680. So you see that you need more energy to form the bonds, and we know that forming bonds releases energy. Okay, so essentially there's an excess of 280. Okay, and then you release energy, so it will be having a negative symbol. All right, so the answer should be B. Okay, otherwise you can use the formula of how to find the energy change, which is taking the energy to break the bonds, take away the energy to form the bonds. Okay, so moving on to number 13, which statements about hydrogen fuel cells are correct? One, the reaction between hydrogen and oxygen is endothermic. No, the purpose of the fuel cell is to produce energy. So you don't want it to suck energy away from you. Okay, it's sucking in the energy that's not exactly accurate. So two, the waste product in a hydrogen fuel cell is water, which is true. That's why we like this cell. Okay, it's essentially clean fuel. Three, a chemical reaction in the cell produces hydrogen, which is used as the fuel. No, right. We say that it produces hydrogen. It uses hydrogen. Okay, it uses hydrogen, but it produces water. So three is wrong as well. So pretty much the answer should. Am I making a mistake here? Wait, let me check. Oh, no, no, no. I'm correct. Okay, so last one. A hydrogen fuel cell is used to generate electricity. That's correct. So answer is C. My bad for misreading the question. Okay. Okay, hopefully that's clear. Moving on, number 14. Which change is a physical change? A, copper to carbonate changes color from green to black when it is heated and stays black when it cools. That is actually a chemical change, as the copper to carbonate is green in color, but when it gets heated, it essentially decomposes to form copper 2 oxide and also carbon dioxide, and copper 2 oxide is actually black in color. So it's actually a chemical change. Okay, so A is not the answer. B, ethanol reacts with oxygen to form carbon dioxide and water. So there's a chemical change here. It's quite obvious. So no. And C, hydrogen peroxide decomposes into water and oxygen when it is boiled. Same thing here, which is there's a chemical change. So D, ice forms liquid water when it is heated. So answer is D. Okay, it's only a boiling process. A boiling process is a physical change. Oh, sorry, my bad. Ice turns into water. There will be melting. Okay, melting is only a physical change. Moving on to number 15, a student adds excess magnesium ribbon to 10 cm cube of 0.5 mole per dm cube sulfuric acid. The hydrogen gas is collected and its volume measured every 10 seconds. The experiment is repeated using the same mass of magnesium ribbon with 5 cm cube of 0.5 mole per dm cube sulfuric acid added to 5 cm cube of water. Which graph shows the results of the second experiment? So we have the original experiment given to us. So let's observe what's the change here. We are using the same mass of magnesium ribbon, but this time we are using a diluted version of our sulfuric acid because you are essentially adding water to the sulfuric acid. So as concentration decreases, for a reaction, we should expect to see rate of reaction to drop. And at the same time, you should think of it as there's limited reagent now, because you must understand that magnesium reacts with the acid, not the water. So since the amount of actual reagent that you are using actually decreases, so that will actually mean that your product should be less than the original. So there's a decrease in rates and also decrease in the production of hydrogen gas. So that will mean that the most likely answer is donkey, D for donkey. Okay, this graph is characterized by less volume of gas produced at the end. Not at the end, sorry. The total volume of gas produced is less. Okay, and also the decrease rate, which means the graph will be lower than the original. Moving on, number 16, an equilibrium reaction is shown. The forward reaction is endothermic. What is the effect of changing the temperature and pressure on the equilibrium position? Here comes the difficult question, which is about equilibrium position. Okay, first change that is applied to this system is we are increasing temperature. When temperature is increased for a reaction that is in equilibrium, it will shift the position of the equilibrium to the endothermic reaction. Okay, so it should be moving towards the right hand side, not the left hand side. Moving on to increasing the pressure. So increasing the pressure of a system in equilibrium will actually change the equilibrium position to the side with less gas particles. So this equation tells us that there is only one gas particle on the left and two gas particles on the right. So it should be moving towards the left hand side. Right. So it should be C. Okay, moving on to question 17. In which reaction is the underlying compound acting as a reducing agent? Okay, students often get confused by this. When you see a substance is acting as a reducing agent, it is essentially undergoing oxidation. Okay, the agent itself undergoes oxidation. So all we need to do is just see, does the underlying compound undergo oxidation? So this one doesn't. There's less oxygen. From 2 to 1, no. B, it does have an increase in the number of oxygen from C to CO2. So the most likely answer is B. We can check the answers for C and D as well, which you see there's a reduction of number of oxygen. And also for D, is not exactly a redox reaction. So the answer should be B. Moving on to number 18. X, Y, and Z are oxides of elements in the same row as the periodic table. Some information about each oxide is shown. Which types of oxides are X, Y, and Z? All right. So for X, it is unable to neutralize an acid but able to neutralize an alkali, which means that it itself is actually an acid. Okay, only acid reacts with alkali. Alkali doesn't react with alkali in terms of neutralization reaction. And then for Y, it is able to neutralize an acid Simultaneously, it is also able to neutralize an alkali, which means that it is having both properties at the same time, which means that Y is actually an amphoteric substance. Okay, amphoteric means that it has both acidic and basic properties. Okay, although the more accurate definition is the ability to neutralize acid and an alkali at the same time. So for Z, it is able to neutralize an acid. So which means that it is a alkali, it is basic, right? So it should be A as the answer, acidic, amphoteric, and basic. Moving on to number 19, 4 different acids are dissolved in water. Which beaker contains the most concentrated strong acid solution? Now, first, we have to understand what are acids. Acids are proton donors, hydrogen ion donors. When you say that it's strong, if you mean that hydrogen ions should be, there should be a lot of hydrogen ions in the solution. You shouldn't look at anything else. So let's count them. In A, there's only 6 hydrogen ions. In B, there is 2 hydrogen ions. In C, there are 3 hydrogen ions. For D, there are 4 hydrogen ions. So among all of this, it should be A that is having the most number of hydrogen ions, which makes it the most concentrated strong acid solution. All right, moving on to number 20. The following substances can be reacted together to prepare salts. 1. Copper 2 oxide and excess hydrochloric acid. 2. Hydrochloric acid and excess sodium hydroxide. 3. Hydrochloric acid and excess zinc carbonate. In which reactions can the excess reactant be separated from the solution by filtration? When you see the word filtration, you should think of separation of solids from aqueous solutions. So where do the solids come? Where do the solids come from? It's the excess reactants. So we have to see, does the solid component is having excess? Right, it's the solid that is in excess. So for number 1, it's the acid is in excess, not the solid. For 2, both of them are aqueous solutions. Hydrochloric acid is an aqueous solution, and then sodium hydroxide is also an aqueous solution. So the only answer possible is 3, which is donkey. All right, moving on to number 21. Salt S is dissolved in water, and 3 tests are carried out on a solution. 1. Aqueous sodium hydroxide is added. You form a green precipitate, which is insoluble in excess sodium hydroxide. When you see the word green precipitate, you should think of either iron 2 ion or a chromium ion. So in the answer options A and B, you can eliminate these answer options. 2. Dilute nitric acid is added. There is no reaction. Nitric acid doesn't actually do much to most chemical substances from the beginning. So I think it's just there to distract you. We should look at 3. Aqueous barium nitrate is added to the acidified solution from test 2. Oh, so it's a, yep. When you do barium test, you need nitric acid. That's true. Okay, so yeah, number 2 is just a step before number 3. Okay, so what is barium nitrate for? Always remember that barium reacts positively with sulfate ions to form a white precipitate. So it means that this solution has sulfate ion in it. So it should be D. 21. The answer is donkey. D for donkey. Number 22. Which statement about the periodic table is correct? A. Most metallic elements are on the left. That's pretty much correct. Right. So answer is A. Let's look at B, C, D anyway. Elements in the same period have the same number of outer electrons. That the more accurate answer should be group, not period. Period has the same number of shells of electrons, not the outer electrons. C, elements on the left are usually gases. That should be on the right hand side, not the left hand side. And in fact, actually, not all of them are gases. Some of them are liquid, and even some of them are solid. So D, the relative atomic mass of the elements increases from right to left. That's wrong. It should be increasing from the left to right. Okay, so number 23, the diagram shows element W, X, Y, and Z in a section of the periodic table. Which statement about the reactivity of the elements are correct? So group 1 is alkali metals. Alkali metals are characterized by their stronger reactivity down the group. That's why we don't allow you to use the alkali metals found at the bottom of the group, like francium, for example. We don't allow you to use that because it's too strong. Okay, and then for group 7, which are halogens, essentially going down the group, the reactivity actually decreases. Okay, so wait, give me a second to write down the notes here. So this one is weaker reactivity. Weaker reactivity. So which statement about the reactivity of the elements are correct? So we can see that Y is more reactive than X and W is more reactive than Z. So answer is C. Right, moving on to the next question, 24. Some properties of substances are listed. 1, they conduct electricity. 2, they have low densities. 3, they have high melting points. 4, they are malleable. Which properties are shown by transition metals? Just like any metal, they conduct electricity, and also they have high melting points, and also they are malleable. So the answer should be 1, 3, and 4. Answer is D for donkey. Now, 25, sodium is a group 1 metal. Which property that is typical for most metals is not shown by sodium? Now, most metals, when you say metals in a general sense, it should be all four, but group 1 metals generally has a lower melting and boiling point compared to the other metal counterparts in other groups. Okay, they are essentially having, comparatively speaking, lower melting point and boiling point than other metals. So it should be B. All right, they still conduct heat, they are still malleable, and they are still shiny. Moving on to number 26. 4 metals, iron, copper, magnesium, and Y, are heated separately with their oxides. The results are shown. What is the order of reactivity of the metals least reactive first? This is a displacement reaction, as you are dealing with taking a metal, reacting with another metal. Allow me to use a different symbol. Maybe I use small m. So another metal oxide, and that gives you the big metal oxide, and the small m is being kicked out from the reaction. Okay, essentially it is still the same old story, stronger of the survival of the fittest. The strong metal takes over the weaker metal's place. Okay, but the condition is the metal should have a higher reactivity comparing to the metal found in the metal oxide. Okay, remember that only strong can take away the position from the weak metal. All right, so let's see. Metal Y is able to displace copper and iron out from the oxides. So Y should be above copper and iron. Then magnesium is able to basically take over all three metals. So it means that magnesium is the most reactive out of all. And then copper is unable to displace any, and iron is unable to displace any. So the most suitable answer is A, magnesium being the one on top with Y found next. And actually, if you do memorize the reactivity series, you would know that iron is above copper. So answer is A. Right, moving on to number 27. Aluminium is extracted from bauxite by electrolysis. Which statement is correct? First of all, aluminium ions are oxidized to form aluminium. That will not be accurate because aluminium ions are receiving electrons, not donating them to form aluminium. So it should be reduced. For B, the cathode has to be replaced regularly because it reacts with the oxygen that is formed. Now, the oxygen that is formed is actually formed at the anode, not the cathode. So answer for B is also wrong, should be anode. And then C, cryolite is added to remove impurities. That's wrong. Okay, cryolite's purpose is to lower the operating temperature. It's to improve the electrical conductivity of the setup, as well as to wait. Let me restructure my idea first. Cryolite helps to improve electrical conductivity, and then it also helps to lower the operating temperature, and also acts as a solvent. Yeah, the last one is acts as a solvent. For the last one, so the answer should be D. In fact, that's correct. It's due to the oxygen gas formed at the anode that ultimately reacts with the graphite electrodes and forms carbon dioxide. And hence, you need to replace them regularly. 28. Some properties of aluminium are listed. 1. It conducts heat. 2. It has a low density. 3. It is strong. 4. It is resistant to corrosion. Which of these properties make aluminium suitable for making food containers for chilled food products? So it only wants the properties of aluminium that helps with this particular function. All right. So first, it conducts heat. Does it help with it being a good food container for chilled food products? No. It has a low density. Is it really good for containing chilled food products? I don't think it's exactly accurate. Right. 3, it is strong. You don't have that answer option as well. Right. So 3 doesn't feel like it as well. But 4 is the best out of all, which is it is resistant to corrosion. That's why we like to put food into aluminum cans. All right. So 4 is the answer for 28. And then 29, water is treated at a waterworks to make it fit to drink. What is present in the water when it leaves the waterworks? So once it leaves the waterworks, it will be fit to drink. So what is added to your drinking water? Essentially, you have chlorine compounds. All right, and once you add chlorine compounds, pathogens and including bacteria also die from the process. So bacteria will not be possible. And then also, actually, there are certain soluble substances which are added, for example, fluoride. All right, so there will be donkey. Moving on to 30. Sulfur dioxide, carbon monoxide, and oxides of nitrogen are common gases pollutants found in the air. Which pollutants contribute to acid rain? So we know that the main gases that causes acid rain are sulfur dioxide and oxides of nitrogen, also known as nitrous oxides. All right, so the answer is B. So you can think of these two compounds, when they dissolve in water, it may form, let's say, for example, sulfuric acid for sulfur dioxide, and then for nitrous oxides, it may form, let's say, nitric acid. Okay, so these are essentially things that you have learned previously. Moving on to question 31. All right, I feel that I might have used the wrong paper for me to discuss this, but regardless, you don't see anything. Okay, question 31. Oxides of nitrogen, such as nitrogen monoxide and nitrogen dioxide, are formed in the petrol engines of cars. They are removed from the exhaust gases by reactions in the car's catalytic converter. Which row describes how oxides of nitrogen are formed in a petrol engine and a reaction that happens in the catalytic converter? All right, what happens in a catalytic converter? A catalytic converter is to help essentially toxic gases such as carbon monoxide and also nitrogen dioxide. All right, these two poisonous. Okay, carbon monoxide is more towards poisonous, whereas for nitrogen dioxide, our concern is it can be contributing to acid rain. Right. So these two gases, we want them to be converted into a safer form. So what's the safer form for carbon monoxide? It will be carbon dioxide. And then what's the safer form for nitrogen dioxide? Nitrogen gas. Right. Nitrogen gas is relatively unreactive. 78% of nitrogen, of the air is nitrogen. All right. So the equation is, so the second one is wrong. The fourth one is wrong as well. So it's either 1 or 3. Now, how the oxides of nitrogen are formed is actually due to the reaction between nitrogen and oxygen from the air. All right, so the answer is A. Okay, moving on to question 32. Zinc is used to cover iron to prevent it from rusting. Why is zinc a suitable metal to use? So you can see that zinc is acting as a stronger metal here. It's trying to protect iron. So in order to protect iron, it must be quote unquote stronger. In chemistry, we call it as reactive. It must be more reactive than iron. Right? So zinc has to be more reactive than iron. So answer is C. All right, think of reactive as stronger. Okay, the stronger metal will protect the weaker metal from rusting. All right, from corrosion. Now, question 33. Fertilizers are mixtures of different compounds used to increase the growth of crops. Which pair of substances contain the 3 essential elements for plant growth? So whenever you see plant growth and fertilizers, you should think of the most popular fertilizer in the industry, which is NPK fertilizers. Right? N stands for nitrogen, P stands for phosphorus, and K stands for potassium. So all you need to do is just check from the answers, which of the answers have all three elements? All right, so for A, ammonium nitrate, the formula is NH4NH3, sorry, NH4NO3, and calcium phosphate, which is Ca2 3PO42. Okay, you know what? I'm not going to write down all the formula. I'm just going to write down the ion species so that it's not too confusing for you. So ammonium is NH4 plus. Nitrate is NO3 minus. What are the other molecular ions in the question? Phosphate is present, so PO43 minus, and also carbonate, which is CO32 minus. Okay, this list of molecular formula, you have to memorize them before your exams. All right, so we see in this question, which one has all MPK? That will be C, right? Because there's ammonium, there's phosphate, which has P, and then there's potassium, which has K, NPK, fertilizers. All right, moving on to question 34. Which role describes the conditions used in the manufacture of sulfuric acid by the contact process? So this one is memorized. It has to be vanadium 5 oxide, and then at a high pressure, sorry, low pressure but high temperature. Right? So for this question also, if it appears in paper 4, the letter 5 is important. All right, please write down vanadium bracket 5 oxide for your answers if let's say this appears in paper 4. Moving on to question 35. Petroleum is an important raw material that is separated into useful products. Which terms describe petroleum and the method used to separate it? So you are separating a mixture of mostly liquids. When you are trying to separate a mixture of liquids, the best way is to do distillation, which is separation based on boiling point of the liquids. So petroleum is more of a mixture, all right? And then the separation method is fractional distillation. So the answer is D. All right, it's impossible to split a compound using fractional distillation. Okay, you're essentially separating the mixtures away from each other. Moving on to question 36. Which statements about propene are correct? Allow me to draw the structure of propene first. When you see the word prop, it means 3 carbons. When you see the word "ene," it means that this organic molecule has a carbon-carbon double bond. So it has 3 carbons, right? Then fill in the rest of the gaps available with hydrogen atoms. And make sure that carbon has 4 lines each because carbon is a group 4 element. All right, 1. Propene contains only single bonds. That's wrong. The word "ene" tells you that it has a double bond. 2. Propene decolorizes bromine water. All right, this is bromine test. Bromine test is positive for alkenes. So the answer for 2 is correct. 3. Propene is obtained by cracking. You can technically get hydrocarbons from cracking, like smaller hydrocarbons from cracking. So 36, 3 is still correct. All right, so cracking refers to long chain hydrocarbons, such as usually alkanes, broken down into smaller chain alkanes and alkenes. All right, so 4, propene is a hydrocarbon, literally. It's a hydrocarbon, which means a compound that contains only hydrogen and carbon. So the answer is B. Moving on to question 37. Which role describes the production of ethanol and its properties? Ethanol is the result of fermentation. If you're using a biological method, or you can use a chemical method, which is known as hydration of ethene. Right? If you observe the structure of ethene, you are adding a molecule of water to convert it into an ethanol. So for the first and the second option, that will be correct. And then ethanol is used as a fuel. That is absolutely correct. And then it is used as a solvent. Yes, we can use ethanol as a solvent actually. So A is the answer. All right, moving on to question 38. Ethanoic acid is a typical carboxylic acid. Which statement about ethanoic acid is correct? A, it can be oxidized to produce ethanol. It should be the opposite. Right, ethanol oxidizes to form ethanoic acid, not the other way around. So answer for A is wrong. B, it is a proton acceptor. Acids are not proton acceptors but proton donors. So answer for B is wrong as well. C, it is fully dissociated in water. Now, ethanoic acid is an organic acid. Organic acid usually is a weak acid, right? Because if it's strong, it would have killed biological organisms, right? Okay, when I see the word organic, it means usually sourced from living organisms. And then living organisms rarely produces strong acids. Like not always, most of the cases, it will be producing weak acid or bases. All right. Only rare cases they produce strong bases or strong acids. So it is fully dissociated in water will be wrong because that will be a characteristic for strong acid or bases. Right, this is a weak acid. So the answer should be D, but let's check the answer anyway. It reacts with ethanol to produce ethyl, ethanoate, and water. That is, in fact, correct. Right, ethanol contributes the ethyl part, and then ethanoic acid contributes the ethanoate part. And then in the process, it removes a molecule of water. All right, so question for 39. Which structure represents the ester made from ethanoic acid and propanol? So ethanoic acid is not hydrocarbon, but it is an organic molecule that is characterized by two carbons and is having a COOH group. Whereas for propanol, the word prop tells you that it has three carbons, and then the word ol tells you that it has a hydroxyl group, which is OH. So all you have to do is observe which one resembles this the most, which one resembles this one the most out of the list. All right, so the part with the COO should be having only two carbons. So A may be possible. B is not possible. C is not possible as well. And then D may be possible, but let's check further. So your propanol provides the propyl part. Right, so A is the answer. All right, so this part, the right hand side, it is the ethanoic part, and then the left hand side of the molecule in the diagram is the propyl group. Right, moving on to the last question. The structure of a polymer is shown. Which statements about the polymer are correct? So 1, the polymer is nylon. No. Right. 2, the polymer is formed by condensation polymerization. That is correct. As we see, it's a amide linkage, which is CONH. Amide linkage is formed via condensation polymerization. So this is not exactly ester linkage. So 3 is wrong, and then the only answer possible is C, 2. All right, so that's the end of this paper. Thank you for watching. Like, follow, and subscribe if you're interested in watching more past year paper discussions. And if you do have any comments or feedbacks, feel free to comment below in this YouTube section. And I'll see you in the next one. Thank you.